Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello future engineers, here is another video in calculus, particularly on composition of functions. If you want to anticipate, if you want to answer the exercise here, you may do so by pausing the video. So if f of x is x plus 4 and h of x is 4x minus 1, find a function g such that g of f is h. So g should be should have a coefficient of 4. Then we substitute f of x, which is x plus 4. So if it is 4 times x plus 4, that would be 4x plus 16. Since the result here is 4x minus 1, so we conclude that g is 4x minus 17. So g of x is 4x minus 17. So to check, let's substitute it here. G of f of x, so 4 times x plus 4 minus 17 is equal to 4x plus 16 minus 17, and it is equal to 4x minus 1. So therefore, g of f, or which is equal to h, is h of x, 4x minus 1. Then second problem, suppose g is an even function and let h be f of g. Is h always an even function? So to answer this, let's have examples of f, which is both even, and f which is an even function, and let's have also an example of f which is an odd function. So for g of x, which is x squared, even, and g of x cosine x, this is also an even function of x. So cosine of negative x is cosine of x. Remember, negative x quantity square remains x squared, so it is unchanged. So that's why these functions g are even functions. So h is f of g, and let's have f of x, which is x cubed odd, and f of x, which is x sine x, which is even, because x is odd, sine x is also odd. So negative x times sine negative x, it becomes negative x times negative sine of x, so it becomes positive x sine x. It is unchanged, so that's why it is an even function. So for f of g, this is g here, substitute here. So x squared quantity cube, so h is f of g of x, and that is x squared quantity cube, and it becomes x to the 6. And if we replace x by negative x, the original result for h, which is x to the 6, remains unchanged, x to the 6. So that's why h is even after we consider f as odd. Then for this situation, f of g, h is f of g, it is f of g of x, so it is cosine of x quantity cube. It becomes cosine cube of x, and replacing x by negative x, f of g is cosine of negative x quantity cube, Remember that cosine of negative x is the same as cosine of x. So cosine of x, quantity cube, will go back to cosine cube of x. And therefore, h is even for that case. Cosine cube of x is even. Because replacing x by negative x, it goes back to cosine cube of x. So that's why it is even. Then, for this second case, f of x is even. So it is h is f of g. It is equal to x squared sine of x squared. So replacing x by negative x, h which is f of g is negative x quantity square sine of negative x quantity square. Negative x square is x square. Negative x square is x square. So it goes back to x square sine of x square. So that's why it is even. Then for cosine x, so we have cosine x sine of quantity cosine x. So f of g is cosine x sine of quantity cosine x. Replacing x by negative x. So we have f of g equals cosine of negative x sine of cosine negative x. And since cosine of negative x is just cosine of x, this is cosine of x, it will go back to this original expression or function. Therefore, h is also even. So for the conclusion, h is always even if g is an even function. So that's the answer. H is always an even function. For the next exercise, suppose g is an odd function and let h be f of g. Is h always an odd function? What if f is odd? What if f is even? So we do the same thing. So g this time is an odd function. So g of x, example of an odd function is x cubed, and g of x is sine of x. Then let's consider f odd and f even. So f of x is x to the fifth, which is odd function, and f of x is x to the fourth, which is an even function. Let's just use these simple functions. So h is f of g. So it is equal to x cubed quantity raised to 5. So that would be x cubed quantity raised to 5, and that is x to the 15. And replacing x by negative x, it becomes negative of the original. Since h is x to the 15, and when we replace x by negative x, it becomes the negative of this x to the 15. That's why it is an odd function. Then for sine x, we have f of g is sine x quantity raised to 5. That would be sine to the fifth of x, replacing x by negative x. Then sine of negative x is negative sine of x to the fifth. Negative 1 to the fifth is negative 1. Then sine to the fifth of x. So therefore, the function is odd. So f of g, which is f of g of x, is f of g is, this is for the second part. So we have x cubed to the fourth when f is even. So that would be x to the 12. And replacing x by negative x, it still remains x to the 12. So that's why it is even, not because of the exponent, but because when we replace x by negative x, the original function h will be unchanged. So that's why it is even. Then h equals f of g for the second part. So sine x raised to 4 here. So it becomes sine to the fourth of x, replacing x by negative x, which is now this. And it is, remember that sine of negative x is negative sine of x. So raised to 4, negative 1 to the fourth is positive 1 times sine to the fourth of x. It becomes the original. So h is f of g, which is sine to the fourth of x. It is unchanged. So this is an even function. So for the answer, final answer, uh, no, h is odd if f is odd, and h is even if function f is even. So that's the final conclusion. H is not always an even function. So h is odd if f is odd, and h is even if f is even. So that's the answer. So this is simplified, by the way, to negative sine to the fifth of x. That's why it is an odd function. So sorry for the not synchronized animation, but I hope you can follow the explanation and the solutions.